Okay, example 1 in 8.2 from Math 20-1. It just asks us to solve them, and if we just tell you algebraically, it's your choice, substitution or elimination. And again, I'm probably going to do more substitution because I do like it a little better. Another way to identify which you should use is, unless you particularly like elimination, I wouldn't really use it unless it was set up for it right off the get-go. And all I mean by that is would need to make sure that our variables had exactly the same coefficient. It is very difficult to solve quadratic linears with elimination if you are eliminating the squared variable. And the best reason to understand that is look at that top equation, 5x minus y is equal to 10. That doesn't even have an x squared. So we would not be able to eliminate the x variable. Now, you can get away with eliminating the y variable. That's not a bad idea. But that's totally up to you which technique you want to use. I am going to do this one via substitution, which means I'm going to take the easier equation, which I think is this equation, and I'm going to isolate for a variable. It doesn't matter which variable, but if you can avoid introducing fractions, do that. So I'm going to add y on both sides, which gives me 5x is equal to 10 plus y. I'm going to subtract 10 from both sides, so I get that y is equal to 5x minus 10. And this expression, 5x minus 10, I'm going to substitute into the y in the other equation. It is very important that you don't substitute a simplified equation into the non-simplified form. If I did that in this question, I would just get 10 equals 10, which is true, but not going to allow us to solve that. And the reason for that is you've basically found where a line intersects itself, which is all points. So we have to take our isolated variable and substitute it into the other equation in our system. And that gives me x squared plus x minus 2 times 5x minus 10. And that's equal to 0. So instead of negative 2y, it's negative 2 times the expression that is equal to y, which I'm just putting a black box around right now. All right, the good news is that's all chapter 8 is. What we have now, although it is a particularly ugly looking one, is a quadratic equation. And in order to solve that, we have to get one side equal to 0. Just to check, we already have that. So I'm going to distribute that negative 2 into the bracket, which means I have x squared plus x minus 10x plus 20 is equal to 0. And then I'm going to collect my like terms. So x squared minus 9x plus 20 is equal to 0. What I need to do is solve that. I'll write that t-chart. I am looking for two numbers that multiply to positive 20, and they have to add to negative 9. The factors of 20 are 1 times 20, 2 times 10, 4 times 5, and I'm going to stop there. Because 4 plus 5 is positive 9, but negative 4 times negative 5 is, negative 4 times negative 5 is positive 20, and negative 4 plus negative 5 is negative 9. So my quadratic factors into x minus 5 times x minus 4, and that's equal to 0. Now this gives me two solutions. Either x minus 5 is equal to 0, which is to say that x is equal to 5, x minus 4 is equal to 0, which means that x is equal to 4. This is why chapter 3 and 4 were so important. And I really can't understate how crucial it is that you're able to solve quadratics. That is not going anywhere. Math 30 constantly comes back and back to solving quadratics, so you're going to see a lot of them. Now, what I like to call these are kind of solution branches, and it's the idea that everywhere in this question, y is equal to 5x minus 10. So if I'm saying that x is equal to 5, then y is equal to 5 times 5 minus 10, y is equal to 15. So 5 comma 15 is one of my solutions. When x is equal to 4, y is equal to 5 times 4 minus 10, which means that y is equal to 10. So 4 comma 10 is another one of my solutions. Now, it is very important that because we're dealing with a linear and a quadratic, we could have no answer, one answer, or two answers. And in this case, we got two answers. If you're doing one of these questions and you get three answers, you have made a pretty dramatic wrong turn somewhere. Please remember that you can exploit your calculator for this. If you were going to do that, you'd have to manipulate the other equation to get y isolated. I'm not going to do that, though, because I do want to focus more on the algebraic side. What I am going to do, though, and I think so many students just don't want to do this for whatever reason, probably laziness in my opinion, we are going to verify it. It's very important that a huge advantage of solving mathematically is that we can always verify our solutions. If you get a solution, you can verify it by plugging your solution into the original equation. And that's really all we're going to do to finish this question off, is I'm going to take that two solution sets, so 5 comma 15 and 4 comma 10, and I'm going to plug them into the original equations. No manipulation should be done when you verify. So 5 times 5 minus the y value, which is 15, should equal 10. This is 25 minus 15 is equal to 10. I get that 10 is equal to 10. That's good. That's not enough. You have to check it in the other equation as well. So is 5 squared plus 5 minus 2 times 15 equal to 0? Well, this is 25 plus 5 minus 30 is equal to 0, and I get that 0 is equal to 0. So for sure, 5 comma 15 is a solution. That point is on both of the equations in my system, so it does solve this system. The other verification we need to make is the 4 comma 10. I'll just overwrite that, and oh, that made it a lot messier than I thought it would. Whoops. So we're going to check 4 comma 10 next. So that's 5 times 4 minus 10 is equal to 10. This is 20 minus 10 equals 10, and that is, of course, true, right? 10 is equal to 10, certainly. All right, we have to check in the other one as well. So that means that 4 squared plus 4 minus 2 times 10 should be equal to 0. This is 16 plus 4 minus 20, and I definitely get 0 is equal to 0, which means that 4 comma 10 is a solution as well. So now we have the two answers to our systems of equations. And the one thing that I'm going to do is I want to show you this graphically. I'm going to cheat a little bit. I'm going to use Desmos, and we'll just talk about where those intersections are, and we can kind of confirm that. I really do want you to focus on the algebraic techniques for this lesson, but it is nice to see it kind of hold true graphically as well. All right, so a little jarring for sure to jump right to Desmos, but I'm cheating a little bit in Desmos. This is a great program, and I do highly recommend you try it out, take a look at it. It's just so friendly to use on a computer as opposed to the graphing calculator. I put my two functions in. Nice advantage of Desmos is I can write them exactly as I see. I don't have to have y isolated. But to make sure you do see that if I did isolate y, what I would have is y is equal to x squared plus x, and then all divided by 2. And we do see that the green and the blue line are perfect. They're the same thing, right? So it doesn't matter if you isolate y on Desmos, you would certainly need to isolate y on your calculator. So if you do want to do this on your calculator, you would have to put in these two functions, and you would get the same thing. So I'll just show you really quickly that if I did look at the purple and the green, they intersect the same place that my blue and red functions do. And just to quickly verify that, Desmos will show you those intersections, and we see that 4 comma 10 and 5 comma 15 are actually the only location where those two lines meet. So that's just kind of a nice kind of maybe graphical proof that what we did algebraically was correct. By no means necessary, but it's never a bad idea to make sure you're on the right track when you do these types of questions.